So good afternoon, everybody. So as I told you guys, any instruction or any command in let me make sure this is working. Yeah. In assembly language has to tell, number one, what operation this instruction is gonna do. Number two, it has to tell you where are your operands. Okay, operand is, as I told you, that means the source of the data. This is operation. This operation needs some data to work on this data, right? So you have to tell me where I have to get the data. For example, to do addition. For example, if the operation is addition. Also, you have to tell me where I have to store the result. That's what we call destination operand. Okay, that's what I explained last time. And now, or as I also told you last time, what kind of operands we may have. For the operand, as I explained last time, guys, I told you operand can be an immediate value, okay? And what we did last time, you remember hashtag? Yes. So to tell me this is an immediate value, you have to put hashtag here, okay? Hashtag and then a number. You can put this number in any format. For example, you can $sign, or you can just put 10, whatever. All of these are okay, but you have to put here $sign. Is that okay? For example, if I say load register A with number 10, what it means? It means I want to store number 10 in register A, because hashtag here means immediate value. Okay? By the way, that's what we call addressing modes, because some of you were confused when we used the word addressing modes last time. So addressing modes. This is the topic I'm teaching right now. It means the different ways I'm going to express the operands. The first one here, this is what we call addressing mode. The first one here, this one is called immediate addressing mode. You remember in the lab, in one question, I told you I want to store this number in register A using immediate addressing mode. So it means immediate value. Is that okay? Any question? Also, your operand, for sure, if it is immediate value, so it has to be source. For sure, it cannot be destination. I'm not going to store the result because this is not a container to store the result in it. So it has to be only source. Okay. Number two, I told you also operand can be a register. Okay. For example, here you have register A, register B. For example, I want to add here register A to register B, store the result in register A, for example, and so on. Okay. So here, and I told you in this case, as I'm going to explain later, in this case, what you have to do, you have to use the name of the register. So for example, I give you one example as I'm going to teach today. We have an instruction, we call it transfer. I can say transfer A, B. Okay, what this instruction is going to do is going to copy register A to register B, copy. So in case of register, if your operand is a register, we just use the letter of the register. Is that okay? Any question? Okay, what is left now? Memory. Because operand can be your operand can be immediate value, can be a register, or it can be memory location. Okay. For memory, okay. Now, for memory, guys, as I told you last time, we have different ways. The first way we have in memory, okay, we call it direct or extended addressing mode. Addressing mode. Is that okay? Mode. And I told you last time, in this case, what you have to do, just give me the address. Okay, because keep in mind, guys, very simple thing, very basic thing. If I want to read or write to memory, I need an address. You have to tell me which location. Very simple, right? However, you have to tell me there are different ways to do that, as I'm going to explain right now. but at the end, I should get an address. Okay? In case of extended or addressing, you are going to give me the address. For example, you are going to say load register A 1000. So when you see something like that without hashtag, because if you put hashtag, it's going to be not memory, it's going to be number 1000. Anyway, so now if you see something like that, that means I want to read the byte. I want to read the byte from location number 1000 in memory. And this mode, we call it direct or extended mode. You just give me the address. That's it. Any questions? Very simple. Also, I told you, if I say load X 1000, what it means, again, if you see something like that, can be any number, 1000, 2000. I'm just keep using 1000, but can be any number. Anyway, so that means I'm going to read from the location 1000. But this time I'm going to read the word, not byte. Okay, so how did you know? Simple. Every time I teach an instruction, I'm going to tell you if this instruction is going to work for a byte or a word. Very simple. So from the instruction itself, okay? So this instruction always is going to read the byte from this location. This one is going to read the word from 1000. And also we agreed when I say I'm going to read the word from 1000, what it means? It means it means 1000 and 1001. Okay? But I don't need to say 1000, 1001. I don't need to say 3000 and 3001. You don't need to say that. Just to give me one address, and if it is a word, I'm going to take this location and next one. Is that okay? Very simple. So that means automatically I'm going to take these two. I'm going to store them in register X. And the way you are going to do it, as I explained to you before, the first byte at 1000 is going to go to the most significant byte, and then the next byte is going to go to the least significant byte. Is that okay? This is what we call direct or extended mode for memory. Okay. So in the lab, last lab, if I tell you, and that's what I said in the lab, if I tell you, write instruction to store the byte at location 2F00 in register A, how can you do it? Using direct and extended mode. Okay, how can you do it? Very simple. This is the same thing, but you have to just 2500, for example, whatever number I give you, just as long as I told you direct or extended mode. Is that okay? Any question? Any questions? Okay, great. Now, for memory, we have actually four formats for memory. Okay, so I'm going to explain more about memory. So for memory, let me give you the big picture here. So for memory, guys, as an example, you can see something like that. If you see something like that, like a number 1000, 2000, whatever it is, 2F00, whatever it is, this is memory. Also, we have other formats like 0, x, 1, x, a constant number, x or y, x or y, okay, x or y. Also, we can use A, B, register D, one of these, only one, x or y. For example, A, x, B, x, or A, y. Okay. Now, next one here is if you have something like that, 1, x plus 1, plus x, or 1, y minus 1, so if you see this one, it's almost like this one, but just I add plus or minus. Okay, guys. So these are the four different formats we have for memory. I already explained the first one. The first one is called direct or extended mode. Okay, guys, keep in mind, regardless of the format you are going to use, I need a location. You have to give me address, but I'm going to give you address in different ways, and there is a reason for that. Okay, so for the first one, this is address. I just give you the address. This here, these four guys, we use them. We are using pointer. Okay, pointer. You know from C language, pointer means I'm going to store the address in a variable. Our variable here, X or Y. You got what I'm saying? Pointer. And as you see, all the time, we're going to use pointers here in this course. We're going to use pointer all the time, usually to read or write arrays, as you will see later. Okay. So this is, but the way we call it pointer, or we call it indexed addressing mode. Indexed means pointer. Okay. That's what we did in the last lab. So in the last lab, I told you we have indexed addressing modes. Okay. And every everyone has this one. As I remember the name, we use this one constant offset. I guess. Okay, let me give you the exact names for each one of this before I elaborate here. So if you go to chapter 2, yeah. Just to understand, when I use this name, you know what this name means. Okay. So yeah, here. Yeah. So under index it again. Don't be confused. Index it mode. So index it means pointer. We're gonna do it in 3 ways, as I explained. The first one is called index it with constant offset. So this one means it has a constant comma x. This constant can be 0, can be any number, or x or y, because our pointer here is x or y. Okay. This is the first one I'm going to explain. Just you should be familiar with this name because that's what we used in the lab. The second one is called index it with an accumulator register offset. Okay. I told you before, register A, B, and D, we call this register, we call them accumulator registers. We call them accumulator because, as you will see later, once you do the addition or multiplication, usually the result is stored in this register. That's why you call them accumulator. So in the lab, in the second part of the lab, so for example, if you have here B comma X, A comma Y, if you have any of this format, you should understand this is memory, one location. This is memory, okay? And this is what we call accumulator register offset. Next one, which I didn't teach yet, I'm going to teach right now. This one here is called auto pre or post increment or decrement and indexed register. Okay, I'm going to tell you why we call it pre increment or post increment or decrement. You can tell from the name, because if you see here we have plus or minus for increment or decrement. I'm going to elaborate. Just I want you to be familiar with these names because that's what we used in the labs. Now I'm gonna elaborate. So what I'm done. I am done with the first one. That's very easy one. Okay. Now I'm gonna go with these 3. Keep in mind, these 3 guys are pointers. We're gonna use pointers. Number 1. Number 2, we're gonna use it to read or write arrays, but just different ways. I'm gonna tell you how we're gonna use them and where. For any one of them, you should understand what is the address. Because anyway, I need to get the address to read memory. You have to tell me which location, okay? So very simple. So the way it works is, okay, so let's start one by one. For example, when I say 0, 0, comma x, or 1, comma x, or 2, comma x, whatever constant, comma x. Okay, guys? So, number 1, what is the address? Very simple. The address is, I'm going to get whatever in x, then I'm going to add the number here. So, you have a number, this number. I'm going to add it to the constant, to x, and this will be my address. So, for example, 0, comma x, that means whatever in x plus 0, 1, comma x, whatever in x plus 1, 2, comma x, whatever in x plus 2. Okay? Very important. It will be in a quiz. I just want to make sure you understand it or not. Okay? This instruction does not change x. So, what's going to happen, as you see here, guys? For example, let me 2, comma x. This instruction, or let me have a specific example. Look here, guys. Load register A 2, comma x. What this instruction means? It means I wanna read the byte. I wanna read the byte from this memory location. Put it in A. Which memory location? Okay, the memory location is X, whatever in X, plus 2. Okay, then this is the address. So I'm gonna go to this location. I'm gonna get whatever there, I put it in A. Yes. Yes, well, so yeah, you can put 0 if you want. So your question is why you put 2, okay? I'm gonna explain later why you may need to put 2, okay? You can put 0, but the format is you have a number here, whatever the number is, okay? But usually small numbers. It's not like 1,000 or something. Usually small number, okay? 0, 1, 2, 3, 4, 8, 4, something like that. So I have constant number, comma X, okay? So here that means I want to read the location, whatever in X plus 2. Okay, now focus on trying to understand now when you see something like that, what it means, what this means, how it works. How I'm going to use it, I'm going to explain right after some time. Okay, so I'm going to explain today how we can use it. I just want you now to understand when you see something like that, how it works. So what's going to happen, I'm going to take whatever in X, add 2, and then this is my address. I'm going to read by from Z, I'm going to put it in A. Is that okay? This instruction does not change X. So I'm not going to add 2 to X. I didn't say that. I didn't say X should equal X plus 2. I didn't say that. Okay, all what I said, whatever in X plus 2, this is my address. I'm going to read a byte or I read a word from this location. Yes. Can be anything. You can use it the way you like. However, as I'm gonna explain, usually we use this one for arrays, but you can use it for any way. Okay, you can use as you like, but usually, as I'm gonna explain how can we use it. Now I want to focus on when you see something like that, what it means, and then I'm gonna explain today how can we use it to read or write arrays. I'm gonna explain. Yes.
What error will pop up if we go beyond the range?
What if you keep reading location, you go outside?
Yes.
So I don't know. You should not do that. Okay. You should already. You have to write. You already have a space for your RAM, right? So you have to write in this space. You have a space for flash memory. So you have to write your program in flash memory. If you make a mistake, I don't know. Compiler is going to give you a. I never did it. That's why I don't know what the kind. But you can tell from the name something like that does not exist or whatever. I don't know. You got what I'm saying? No, you mean what error if you go outside array? That's your question?
No, outside
memory. Okay. No, I think a compiler is gonna give you some, or maybe compiler is not gonna give you error, but during the execution you are gonna get error somehow. You got what I'm saying? Anyway, so same thing, guys. If I use the same instruction here, if I say load X or sorry, load Y, so load G, register G, okay, 2, X. What's gonna happen? I just for now I want you to focus to understand. If you see something like that, what it means? It means this is a memory. This is not 2 operand, 1 operand. That's a memory. Okay, that means I'm gonna read the word, put it in G, a word from which location. I'm gonna read the location 2 plus X and next one. So I'm gonna take these 2 locations. I'm gonna put them in G, register G. Is that okay? Okay, so in the lab, and that's what I did. If I tell you in the lab, I want to read the location. This was a question in the lab. I wanna read the location, for example, 1005. Okay, guys, using this addressing mode, constant indexed address mode. How can you do it? There are several solutions. Number one, you can say load X. Okay, load X with 1005. Hashtag. So now I'm gonna put 1005 in X, right? Then I'm gonna say load accumulator A 0, X. So I wanna read the byte from the location X plus 0. So X plus 0 is 1005. Okay, so I already did it. This is the answer to the question in the lab. Is that okay? Some students can do it in a different way. Some student can say, okay, but I'm gonna put here 1. Yes, okay, put here 1, but you have to subtract 1 from here. You got what I'm saying? So 1004 here, 1 comma x, you are gonna add 1 plus 1004. So this address is gonna be 1005. You got what I'm saying? Some student is gonna put here, for example, 2. I'm totally fine, but you have to make it this one 3. So that when I add the constant number plus whatever in x should give me 1005. Is that okay, guys? Again, for now, try to focus to understand what this means. When you see something like 0, comma x, 2, comma, what is understand? I'm going to explain how can we use it to read or write arrays, okay? But let's focus on this one first. Any questions? Okay, let's move to the next one. Next one here, as I told you, what we call it accumulator. Which is exactly same idea. When I say, for example, A, you can use A, B, or C, okay? And then you, G. And then you can use X or Y, comma X or Y, okay? So that means I can say A, comma X, A, comma Y, and so on, okay? For example, if I say load accumulator, for example, A, B, comma Y. What this means? It means this is a memory. When you see something like that, that means this is a memory, right? So I want to read the byte. From this memory location, put it in A. Is that okay? Which location? The location should be B plus Y. So I'm going to get whatever in Y, whatever in B. I'm going to add them together, and this is going to give me the address. I'm going to read whatever there, put it in A. Okay? So in the lab, if I tell you in the lab, use this addressing mode to read the location 1005. How can you do it? Very simple. All what you have to do, guys, I have to put some number in B, some number in Y, so that when I add them together, I'm going to get 1005. You got what I'm saying? So that means some student can put here 0, some student can put here 1005. So when I add them together, I'm going to get 1005. Yes. So before this instruction, you have to say load register B with number 0, load X, Y, load Y with 1005. Yes, this is the answer of the question in the lab. Is that okay? There are other solutions. You can put here 1, you can put here 1004. So 1004. That's true. Any number, so that when I add them together, okay, the result will be 1005. Is that okay, guys? Very important. This will be in the quiz on Thursday. I just want to make sure you understand it. I didn't say this instruction is going to change Y or B. Okay? So this instruction, I didn't say the result will be stored somewhere. No, I'm going to just use Y. I'm going to use A or B, whatever you are using, just to calculate the address. That's it. But I'm not going to go back and put it in Y. I didn't say that, right? That means before you execute this instruction, before or after, B or Y should be the same. Because this instruction does not change here. This part does not change B or Y. We just use them to calculate the address, but I'm not going to change them. So in the coming quiz, I'm going to tell you, execute the instruction. After the instruction, I'm going to tell you, what is the value of B? What is the value of Y? Is that okay? So before I take these questions, look here. So what I said, guys, I explained two types. I explained constant like 2, X, 2, Y. I explained A, X, B, Y. I told you guys, these two types, they don't change Y or X or A or B. They don't change them. Okay, so after you execute it, so if you use this one, X will be the same, Y will be the same. Because we use A, B, and Y or X just to calculate the address. The only one that's gonna change X and Y when you add plus or minus, as I'm gonna explain right now. But these two, no. Remember, I explained for memory, we have 3. We have 3 format for memory. Okay. For pointer, we have this one, we have another one, as I'm gonna explain right now, that has plus or minus. Yes, you have a question here?
So since the only A become a Y, load Mr.
A. Let me make minor correction. First, you are right when you say, and this is a memory. So I'm going to read the byte from memory, put it in A. You are right. But I'm going to read the byte from the location pointed by Y, X, or whatever, X or Y, whatever, X plus B, whatever you are using here. You got what I'm saying? So this gives me the location pointed by X or X plus B. You got what I'm saying? So number one, I'm gonna add B plus X, right? To get the address. Then I'm gonna go to this address, read the byte from there, put it in A. You got what I'm saying? And then I'm not gonna change B or X or whatever you're using. Yes. I'm not gonna change Y. I'm gonna read whatever in B. I'm gonna read whatever in X or Y. I'm gonna just add them to get the address. But I'm not gonna add A to X or Y to X. So I'm not gonna change X. Because I'm saying I'm gonna get the number from X. The number from here, add this number to get the address. But I'm not gonna update. I'm not gonna change B or X. Yes.
I thought we was so take the how many press of Y. I could see
I don't like to use, I know accumulator. The reason it's called accumulator because it's somehow related to the hardware. It's not related to this. So I don't want to mix things together. Because in the hardware, usually when you store the result, I'm going to use it in one of these registers, A, B, and D. That's why the hardware people, they call it accumulator. So it's for hardware reason. It's just a register. Is that what I'm saying? Any questions? I'm going to give you example how can you use it to read arrays or write arrays. So maybe you can understand it better. Okay. So one more, the last thing I want to teach right now, guys, is the last format we have for memory. The last thing I want to teach for related to this part. Yeah. So this is the first case. I explained this one. If you see something like that, that means it's one operand from memory and it is memory. I'm going to read a byte from the location pointed by X plus 0. So I have to get whatever in X at 0, and this is going to give me address. I'm not going to change X. Okay, whatever is there, I'm going to put it in A. This slide is very useful, right? Same thing. This is similar to what I explained. The only difference, I'm going to read the word from here. So I'm going to read this one and next one. These two slides are very important. Also, I'm telling you here, before you execute this instruction, if X is 1000, after you execute the instruction, X is going to be the same 1000 because this instruction does not change X. This will be in the quiz. I'm going to give you this instruction this way, and then after executing the instruction, I'm going to tell you what is the value of X. Should be the same because this one does not change X. We have another one that's going to change X. It's coming right now, but this one doesn't. Okay. For case 2, it is the same thing. Accumulator one of these, X or Y. So it's almost the same thing. So I'm going to read whatever in B, whatever in X, add them together. This should be give you address. Okay. And this instruction does not change B or X. Okay. So after execute this instruction, what is the value of B will be the same. Okay. X will be the same. I'm gonna just take this number, read this number, add them together to get the address. But this result, the addition is not going to be stored anywhere. Okay, just to get the address. Okay. So here I just want to give you some idea how this can be used to read memory locations in arrays. For example, if you have an array this way, guys, all what I have to do, number one, I have to initialize X. Very important. We will do it all the time. I have to initialize X with the beginning address. So assume this is array. We have byte every chair here is a byte. Okay. So what happens is that one way to read memory, I have to initialize X with the beginning address of the array. So X is going to be here. And then 0, X is going to give me this guy. 1, X, that's why we add number. Because X is the beginning. Plus 1, I'm going to get element 1. Plus 2, I'm going to get element 2. Plus 10, I'm going to get element 10, and so on. You got what I'm saying? Anyway, you can use this way if you want. Okay? Because X is going to be the beginning address. So if you add 0 plus X, you are going to get element 0. You add 1 plus X, you are going to get element 1. This is okay. This is if it is array of bytes. What happens if it is array of words? Any guess? Yes. That's true. Every time I have to add 2. Yes, because every element is going to take 2 locations. You got what I'm saying? So this is array of bytes. So that means here, for example, I'm going to say 0, X is going to give me, I'm going to read the word from 0, X. So X is here. I'm going to read the word, these 2 guys, because these 2 together is 1 element. Then I'm going to add 2, because 0, 1, 2. So 2, X. So 0, X, 2, X. So I'm going to read this one and read this one. Then I'm going to add 2, 4, X. You got what I'm saying? Makes sense, right? Because every element is going to be 2. So every time I'm going to read 2, right? So if it is array of words, it has to be, this is array of bytes. It's okay because every element is 1 byte. If it is array of words, it should be 0, X, 2, X, 4, X, and so on. It has to be this way. Yes. Okay. Any questions? Question is, how I told you before you do that, you have to initialize X with the beginning address of the array. And also this was a question in the lab. Okay. How can you do that? I'm going to tell you how. And this is related also to what I explained last time. Last time I told you guys when you, for example, here, let me explain it here. For example, if I say org 1000, and then I'm going to define array. I'm going to say buffer, just any name. I want to call the array buffer, dc.b 3759. Is that okay, guys? This way. Okay. So now, because this one, this array comes right after 1000. So this array should start from location 1000. Is that okay? So I can, if I want to initialize X, I can do something like that. I can say load X with number 1000. Is that okay? Or there is a much better way. What is the much better way and why it is much better? I'm going to tell you why. I can say, look here, load X hashtag buffer. Very important. Buffer is just the name of the array. Why this one will be similar to this one? Why? Because remember, and this was in the last quiz, I told you every time you use the word buffer, the code warrior is going to replace it with the beginning address. So this one is going to be replaced by 1000. Is that okay? This is how we are going to do it all the time. All the time. If you have an array and you want to initialize X or Y, you have to do something like that. Load X, hashtag, and then the name of the array. By this way, I'm going to put the beginning address in X or Y. Why this is much better than just, why you overcomplicate it? I can just put 1000. Why you have to do this way? Can anyone guess why? Yes. Yes, but also there is a more important reason than that. Okay, you know what? I'm going to tell you. This is an easy case. This array just to come after org. So it's easy to know this one is going to come for 1000. Okay. Imagine if you have here 20 variables. Some of them are bytes, some of them are words, 3-4 arrays as well. You got what I'm saying? So you have to count. You have to count. I'm gonna start from 1000, and we have a byte, we have a word, we have a byte, we have array, so we have to count in order to find where is the exact. You remember when you, in the last quiz, when you draw the memory, right? So you have to count. You have to know where it is exactly. So why I bother myself? All what you have to do, guys, just put the name of the array this way, and the code warrior is gonna count on behalf of you, is gonna count, and then put the number here, the beginning address here. That's it. Do you understand what I'm saying? If you have any question, raise your hand. Okay. Let's have another way, as I told you here, guys. This way, I'm gonna use the same idea to read memory, to read array. So the way I'm gonna do it, guys, is I have to initialize X with the beginning address of the array. Same thing. For example, if this array is gonna start, if you have, okay, let me. Okay, so for example, if you have array, this array starts from location 1000, for example, okay? So, and next element in 1001, 1002, and so on, okay? So all what I can do, I can initialize X with the beginning address, for example, 1000, this way. And then if I use B comma X, look here, guys. And then if I put here in B0, so in this way, I'm going to read this location, right? But if I put here in B1, so I'm going to read element number 1. You got what I'm saying? So that's why this one is like offset. You know what offset means? I have X here, X is here, and then I'm going to offset X. I'm going to shift by B because it's going to be X plus B. You got what I'm saying? So if I want to read the element number 27, very simple, just to put 27 here in B, because it's going to be the beginning address plus 27. You got what I'm saying? This is how we can read the array. So here, if I want to read the array, I'm going to keep X fixed at the first location. Then I'm going to add offset. Okay? If I add 0, I'm going to get element 0. If I add 1, so this one plus 1, I'm going to get element 1. So I put this offset in B. Is that okay? So that's why this one can be used to read array. Same thing as I told you. If you don't know the beginning address, or it's going to be difficult for you, just to put the name of the array. That's it. If the array is called, for example, temperature, whatever is the array, what is the name of the array, code warrior is going to replace it and put the beginning address for you. Okay. Okay. Yeah, that's exactly what I'm explaining here. Look, guys here. Org 1000. Okay, buffer this 3725. Okay, so if again, this is also another way. If I want to read these locations of the array, I can say load A 1000, load A 1001, 1002, 1003, and so on. Okay, so this is one way. Okay. However, usually you are not going to do this way, but you can if you want. You can say, I want to read location 1000, location 1001, location 1002, 1003. You can do this way. However, you know from C language, usually if you have an array, especially if it is a big array, if this array is 1000 elements, should I write here 1000 instruction? No one is doing that. That is why they invented loops. Okay. So that's why you are going to use pointers. So if you want to use loops, you have to use pointers, as I'm going to explain right now. So for example, here I can do, so I can, X is pointing at the first location. I can use this one, but still there is no loops here. Okay. Yeah, that's what I'm explaining here, guys. If you want to read a big array, usually you are going to do this way. Look what I'm doing here, guys. X, number 1, I have to initialize X with the beginning address of the array. Very easy. This number 1. Number two, this is a loop. This is how we are going to make loop later, okay? If you are, don't focus on the loops because I'm going to teach it later anyway. So look what I'm going to do, guys, here. In the first iteration, I want to read the byte pointed by X, and the X is pointing at the first location. I'm going to put it in A. And then at the end of the iteration, I'm going to increment X. So that when I go here, now X should equal 1001. Then I'm going to read. So here, that's exactly what's happening here. X is in the very beginning address, for example, 1000. Then in the first iteration, I'm going to read 1000 plus 0, which is 1001, put it in A. Then I have to increment X by 1. Then go back for the second iteration. Very simple. So X is here. I'm going to read the location pointed by X, use it. Then increment X. This is iteration number 2, iteration number 3, and so on. So every iteration I have to increment X. So here, because this is an instruction, you have to use to increment X. That okay, guys? Make sense? Any questions? Okay. Or I can do it if you want to use this format. So already I explain how can you read a big array using loops. For sure, I'm going to teach loops also using pointers, as you see here. Okay, every iteration I'm going to increment X. I can do the same thing in the same way, but this time, again, just different ways. This time I'm going to fix X. X is fixed, but I'm gonna increment B. So what happens here, for example, X is gonna point at the first location, for example, 1000, whatever it is, okay? Then here in the first iteration, B is 0. Then next iteration, B is 1, B is 2, and so on. So the idea is that X is here. X plus 0, I'm gonna use this guy. X plus 1, X plus 2, X plus 3, X plus 4, X plus 5. So where you're going to put 0, 1, 2, 3, 5, where in B. So again, this is just a different way to do it, okay, to use it. So here, I'm going to fix X. X is pointing at the first location. I'm going to do this way, hashtag, okay, because the code runner is going to replace this one by the address, okay. And then in every iteration, I'm going to increment B, but I'm not going to change X. So X is always pointing at the first one, but I'm going to add a shift. Add a shift. X plus 1, X plus 2, X plus 20, X plus 30. Okay. Any questions? So every iteration, I have to increment something. Either if you are using here, you have to increment B. If you are using here, you have to increment X in every iteration. Is that okay? Any questions? Okay. Now, let's come to the last format. The last format is called indexed with pre or post increment. Pre or post increment, okay? So what this one is going to do, okay, I'm going to tell you, first, I'm going to explain something already you know in C language, because it's similar to what I'm going to explain right now. Remember in C language, you remember when you did something like that, Y is equal X plus plus. Do you remember this one in C language? What this means? They told you in this language, this instruction is equivalent to 2 instructions. Y is equal to X and then increment X. This is C language. Is that right? And they told you this is post increment. Why it is post? Because you assign first and then you increment. That's why it's called to post. You assign and then you increment. Is that okay? So, and they told you this one is similar to these 2 instructions. The only difference is this instruction just to compact. Okay, guys? Great. So also they told you if you put the plus before, it's going to be called pre-increment, as you see here. So if you put the plus here before, it becomes pre-increment. Pre-increment means I'm going to do the same operation, but the order is going to be, this one will come first. So it's going to be, I'm going to increment first, and then I'm going to put the updated value for X, put it in Y. Are you okay with these 2 guys? Because what I'm going to teach you right now is exactly something similar to this one, right? So what I'm teaching, in both, what I want to say, in both cases, you are going to do 2 operations. In both cases, you are going to assign X to Y, you are going to increment X. The only difference is that between post and the pre is the order. Which operation I have to do first? Should I increment X first and then assign it to Y, or assign the old value for x before I increment it and then increment x, which operation has to be done first. This is the difference between post and pre. Pre means I have to increment it first. Is that okay? Same thing here. I talk about increment. You can actually decrement. If you put here minus, it will be the same thing, but you are going to decrement x instead of add 1 to x. Is that okay? So this is what we're going to do. Same thing right now. Look what I'm going to explain now. Very interesting. What I'm going to explain right now. Look here, guys. Let me come back here to understand what I want to say. In every iteration, as you see here, I'm going to read a byte. I'm going to read a byte pointed by x, and then I have to increment x. Make sense? So in every iteration, I have to do these two. I have to read, if you want to read an array, I have to read, then I have to increment x. So that in next iteration, I'm going to read, increment x. Okay? What I'm going to do right now, I'm going to have like a short format. Instead of having two instructions, one here to read and one to increment, I'm going to put them together to make one instruction. This instruction is going to do both. It's going to do this one, and then it's going to do increment, but using only just short, compact or short format. So that's what I'm teaching here. If I say load accumulator A 1, x plus, what this means? Okay, what this means? 1, x plus. It means, okay, number one, this one is going to load 0, x and then increment x. So I'm going to read first, and then I'm going to increment after that because this one is post. So I put all of them here. I put all of them here. Look here, guys. So if I say load accumulator A 1, x plus, is that okay? So this instruction actually is 2 instructions, but actually this is just a short format. So number one, I'm going to read a byte from the location pointed by x, 0, x, and then I increment x. So this is increment is post because I put the plus here. If I put the plus here, as you see here, guys, if you see here, if I put the plus here, so I'm going to increment first and then I'm going to read. You got what I'm saying? Why? Because I'm reading an array. In every iteration, I have to read and increment x. Read, increment x. Okay? Every iteration, read and increment x for the next iteration. Is that okay? So again, this is the third. This is if you see something. So this is the only addressing mode that is going to change x. This one is going to change x. Okay. But if I remove plus, if I remove this plus, so this is what I explained before, 1, x. This one does not change x. Okay. So same thing, we have decrement here. Okay. So for example, if you want to, I think I have example here. Yeah. So let's have very important to understand this one, guys. When I say load A 1, x, this will be in the quiz. I just want to make sure you understand what this means. Also, you understand this one is not going to change x, right? So here, this one does not change x. So here, I'm going to read the location pointed by x plus 1, put it in A. However, if I do this one, this is the one, if you see plus before or after x or y, plus or minus before or after x or y, that means this instruction is actually 2 instructions, just a compact format. So this one, I'm going to read the location pointed by x, then I'm going to increment x. But which operation you have to do first? Should I increment first and then load, or load and then increment? Which one? It depends where you put the plus. Here, this plus is post, right? If you put it here, you are going to increment first. So what this instruction is going to do, I'm going to read the location pointed by x, put it in A, then I'm going to increment x by 1. Yes. Instead of what? This one, right? Or this one? Oh, no, this one. Yeah. Because what this instruction is doing, okay? You are gonna read I'm gonna read the location pointed by x, then increment x, or increment x first, depends on where you put the plus. You got what I'm saying? No, I get that part. Yeah. I know what's confusing you. This one, it doesn't mean I'm gonna read x plus 1. It doesn't mean that. This one means I'm going to increment 1, not 2. When I need to use here 2, can anyone guess? Instead of 1, I'm going to use 2. So again, that's good. Your question is good. What confusing you is this one is different from this one. This one here, it means the address should be x plus 1. This one here, how much I'm going to add to x. But in all cases, I'm going to read the location pointed by x, right? But before you increment or after, that's a different story. You got what I'm saying? But this is how much you are going to add. Yes. X is a pointer to the first location in the very beginning. X should store an address. In the very beginning, X should be at the first location, right? Then in every iteration, I have to increment X. So in one iteration, I'm gonna work on this element. Then I have to increment X so that in second iteration, I'm here. Third iteration, I'm here. Fourth iteration, I'm here. In iteration number 10, I'm here. Because I'm saying, so every time I have to increment X. You know what I'm saying? So let's return to my question. My question here, I'm saying, because this is array of bytes. Array of bytes. So every iteration I have to increment by 1. However, if it is array of words, I would put here 2, not 1. So if you put here 2, what it means? If you put here 2, if I put here 2, that means this one should be incremented twice. Okay, so actually it's going to be x should equal x plus 2. And this is what confused this student when he thought this number should be here. No, this number is actually how many times you are going to increment. So here, if it is array of words, it has to be 2 comma x plus. You know what I'm saying? Because I have to read this one. I'm going to read this 2 and then increment by 2. Every time you have to increment by 2. Makes sense? For some reason, if you want to increment by 3, yeah, you put 3. But I don't know why you are. Maybe you are going to have array and every element is going to take 3 bytes. Maybe you. So every time you want to increment by 3, yeah, you can put 3. If you put 5, so every time you are going to increment by 5. Yes. But I'm focusing, or most of the time we are going to work on arrays, array of bytes or array of words. That's why either we are going to increment by 1 or increment by 2. Okay, array of bytes or words. Is that okay, guys? Okay, that's what I'm explaining here. If it is array of words, you have to put here 2 comma x plus. Okay, maybe I'm here. This example is confusing because I use x and x, so students are confused. Sorry, let it make it d. I'm sorry. Okay, so here I'm gonna read the location. I'm gonna read the location pointed by 0 comma x, put it in register d. Here I'm gonna read the word, right? I'm gonna read the word, and then every time I have to increment x by 2. Any question, guys? Okay, so same thing here. If you someone can ask me, so but look here, guys. Here I explain in programming. I have to explain everything, right? Because these are tools. Depends on the programming problem. You can decide what tool you are going to use. You get what I'm saying? Some of the tools you may not use at all, maybe. Okay, that's why I'm explaining everything here. Okay, so but I can just tell you this one is going to read and then increment. Okay, so if you want to use this one, for example, to read array, so in the very beginning, x has to point at the first location because I'm going to read and then increment, right? For some reason, I don't know why. If you want to use this, you can use this one all the time to read arrays. I'm totally fine. But again, I'm saying these tools. For example, if you want to use this one for some reason, this one is going to increment first. So when you initialize x, it has to be one byte before, so that when I increment, I'm going to read the first element. Okay. Again, I don't know what you would use it, but you have to consider this one you increment first. You got what I'm saying? And then read. Right? This one here you decrement. I never use this one, but again, I'm teaching tools. Maybe in some programming problem, you may need it, right? So here you decrement. The way I think about it, I can use this one to read array, but not beginning to end, maybe from the end to the beginning, because every time you decrement, you got what I'm saying? So if this is an array, if I put x in the beginning, so every time I can increment. Is that okay? Maybe, I don't know why, but maybe for some reason, you can put x here at the end of the array. And then you decrement. you can use this one because these two are going to decrement. Is that okay? But anyway, I don't think we're going to need it. But again, this is just a tool. Okay. Any questions? Quiz on Thursday. Thursday quiz is going to be about addressing modes. Okay. So the way it will be, I just want to make sure you understand when you what this all addressing mode means. So let me see if I have. So here you have a lot of examples here. Yeah, maybe it's going to be something similar to this one, guys. For example, here, if I'm going to give you something like that, I'm going to tell you load A number 10, and then I'm going to ask you what is the value of 10. Okay, then I'm going to ask you what is the value of 10. I just want to make sure you understand what this means. Okay. Also, I want you to understand what this means. That means I'm going to read a byte from the location 2000, put it in A. So you have to go to location 2000, see whatever is there, and this should be in A. Okay. I just want to make sure you understand this one. I want to make sure you understand here. I'm going to read the word. When you load the word, you are going to read the word. So this one is going to read. You are going to read to location. Put it in Y. You got what I'm saying? So that's exactly what I'm going to do. I'm going to give you something like this one. I'm going to give you some instruction like this one. And then I'm going to ask you to do this. That's what you have to do. I just want to make sure you understand what this one's, everything I explained here about addressing mode. For example, if you have something like that 10 plus X, 10 comma X, see what is the initial value for X? X was 1000, right? So X was 1000. I'm going to add 10, so it should be here. 10 means A. This is decimal 10, which should be A. So should be here. So that means I'm going to read the byte from this location, put it. So I'm going to read this byte here, put it in A. Okay. Again, nothing is new. That's exactly what I explained here in this part. So the coming quiz will be about it. Okay. Any questions? I just want to make sure. Also, as I promised, I'm going to after you do this instruction, I'm going to tell you what is the value of X. Okay. Because I told you, if you use, I'm going to repeat it again. When you use 0, X, 1, X, 2, X, when you use A, X, B, X, D, X, something like that, these instructions don't change X or Y or A or B or G. So they don't change. These instructions don't change them. The result is not going to be stored anywhere. The only instructions that are going to change X or Y when you have plus or minus. So when you have 1, X plus or 1, plus X. This instruction, because this is a compact version, as I told you, this is actually 2 instructions, read and increment, or increment and read. So that's why this is the only instruction that's going to change X or Y. So I just want to make sure you understand what addressing modes are going to change X or Y, and what address mode are not going to change X or Y. Okay, so this also will be in the quiz. Okay, any question? Okay. So I know students are usually, I spend much time on the addressing mode. I know because this is an important topic, or I'm going to use it all the time. Usually students are confused, especially the student usually confused about, is that, do you mean address, or you mean that you are going to read the location pointed by the address? But anyway, but we're going to use it all the time, and I think you will understand it very well as we use it. Okay. So starting from right now, guys, right now I'm going to start teaching assembly instructions. When I teach assembly instruction, I'm going to start. For sure, I'm going to use these address modes for sure in all the instructions. Is that okay? That's why I wanted to explain the address mode very well. I spent too much time on it. Also, you have a lab so that you understand very well, so that when I use them in instructions, you understand you understand them. Okay, hopefully. One more thing here in the table. You remember this table, guys? So for this table, now I have everything in this table so far. In this table, in the instruction set table, here you have the assembly code. I'm going to explain them. Also, you have here what operation, description to this operation, what this one is doing, as I explained to you before. This is the machine code, as I explained to you before. This one, remember, this one should tell you how many cycles this instruction is going to take, how many cycles, and then you can calculate how much time it's going to take to execute this instruction, right? This one, as I explained to you before, guys, this one can tell you, this column can tell you what flags are going to be updated by this instruction. But because, as I told you, some instruction, it depends. Some instruction update all flags, some instruction update some flags, don't change other flags. So it depends. So this one can tell you what instruction are going to be. For example, if you look at this one here, guys, look here. So this instruction does not change the carry flag. This instruction is going to put 0 in the V flag. This instruction is going to change, is going to update the N flag and Z flag, for example. Okay. So the last column I didn't explain here, guys. This one. So there is another column here. This column is called addressing modes. So this column should tell you what addressing modes you can use with this instruction. You got what I'm saying? Can use immediate value. So here IMM means immediate value. That means with this instruction you can use immediate value. Hashtag. You can use direct. You can use extend. You can use index and so on. So here. In the instruction set table, guys, this column can tell you exactly what address mode you can use with each instruction. Any questions? Okay. Now I'm going to start teaching assembly instructions. Okay, so I'm going to start, as you see here, guys. So I divide them into sections, as you see here. We have data transfer instruction in one section, arithmetic instruction in one section, branch and loop instructions, shift and to rotate instruction, Boolean logic instruction, and so on. Into section. So I'm going to start with data transfer instruction. Okay. What do you mean by data transfer instruction? Very simple. Data transfer instruction, guys, okay, is similar to equal in C language. So data transfer instruction, as I'm going to explain right now, guys, this is similar to equal in C language. We don't have equal here. Do you remember in C language when you did I is equal to 2, I is equal to J? Is that okay? How can you do same thing here? How can you do same thing? Okay. Where now I can be a memory location or it can be a register. So how I can make register is equal to register. Register is equal to memory location. Memory location equal to memory location. A memory location equal to a number. Register equal to a number. You got what I'm saying? How can you do that? We do that using instructions. We don't have equal here. We have, instead of equal, we have instructions. Yes. Yeah, load. So here, load is one of the data transfer instructions. So we have more than other than load. Okay. So I'm gonna teach. So that's all what we have. If you look here, guys. So load instruction is used if you wanna copy a memory location or immediate value. Memory location or immediate value. Immediate value means a number. So if you wanna copy a memory location, immediate value to a register, you have to use load instructions. Right? If you wanna store, or if you want to copy register to a memory location, you have to use store instruction. If you want to copy a register to register, you have to use transfer instruction. If you want to copy memory location or immediate value to another memory location, you have to use move instruction. Okay, guys, very simple. So now we have load, we have store. That's what I somehow explained quickly so far. Now I'm going to add transfer, I'm going to add move instruction. By the way, we use different English names like transfer, like move. All of them are going to be copied. All of them are going to copy. We say transfer, but it's just a copy. Just we use English names. All of them are copy. You copy. Okay? You copy one register to another. Is that okay, guys? Now let's go to the details. This is the big picture. So the big picture is very simple. If you want to copy immediate value or memory location, content of memory location, or immediate value to a register, load, store. If you want to copy a register to memory location, if you want to copy memory location by byte or word to another memory location, move. Or if you want to copy immediate value, I want to put a number, immediate value in a memory location, move, right? Transfer. Also have another one in addition to transfer, we call it exchange. So transfer or exchange. So transfer or exchange is going to be used for register to register. Okay, guys? And as I told you, for each instruction, I'm going to tell you if it is for a byte or word for each instruction. Okay? Any question? So let's go to the details. So as you will see, guys, as I teach this topic, as you will see, okay, some instruction, as you will see, as you will see in this chapter, some instruction does not need any operands, like it has only opcode. Most of the instruction you have to put opcode here, and then you have to put one operand. Some instruction is expecting 2 operands. Very few instruction you have to put opcode, and then you have to put 3 operands. Is that okay? So someone can tell me, is there an instruction that doesn't need any operand? Sometimes yes. Why? Because sometimes the operand itself inside the instruction. For example, when I say increment x, do I need to put anything here? I don't, because it's increment x. So it's not increment, and then you have to tell me what increment. No, it's increment x. So this one doesn't need to put anything next to it. That's why this way we call it inherent. So the word inherent means it doesn't need operand. Okay, like increment x. So I don't need to put anything next to it. That's why we call it inherent. Okay, so you should understand what. So later when I say this instruction is inherent, you understand that means this instruction does not need to put operand next to it. Is that okay? And then for sure this operand is here can be any for as I'm going to explain, it's going to be what I explained to you before. So it can be immediate value, it can be memory location, it can be register. Anyway, let's start. As I told you, data transfer instruction is used if you want to do something like that, but in assembly, where I or J can be memory or a register. So I can put immediate value in a memory or immediate value in a register. I can put a register to register, right? Or I can put register to memory or memory memory to register. Is that okay? So all combination we are gonna have them here. Okay. So let's start with load. That's what I said here. So let's start with one more thing. Also, I want to see here, guys. Okay, let's start. So number one, load instruction. How many instructions we have for load? We have this one, guys, as I taught before. Load accumulator A, and then you have to put here a byte, operand, one operand. This operand can be immediate value or can be a memory location. What this instruction is going to do, this instruction, you are going to read the byte, you are going to put it in register A, right? And this memory can be any format of this memory. So it can be this one or this one or this one, any format, right? The next instruction, load accumulator B or register B. Also same thing here, you can put it here. So this instruction, you are gonna read the byte from memory or put it in register B. Or you are gonna put immediate value in register B. Immediate value, hashtag, don't forget, okay? We have 3 more instructions for load. We have load register D, load register X, load register Y. These 3 instructions, you are gonna read word. This word, you read it from memory or it is immediate value if you use hashtag. Is that okay? That's all what we have for load, okay? For store, so if you look here, guys, the only 2 instructions that are gonna work on bytes, load A, load B. These are gonna work on words. For both of them, all of them, they need only one operand next to here. This operand can be immediate value or it can be memory location using any of these formats, okay? That's all what we have for load. For store, it's gonna be exactly same instructions, but remember, store, you are gonna store a register in a memory. So there is no immediate value here. I'm not gonna store a register in immediate value. It doesn't make sense. Immediate value is not a container, okay? So anyway, that's what we have here. So exactly same instruction, but here always you have to put memory here. Again, when I say memory, it means it can be this way, that way, Or it can be, I forgot the other one. It can be 1 comma x plus. Okay, so this is the meaning of memory. To make your life easier, listen to me, to make your life easier, to make everything easy, keep in mind, every time you see something like this one, without hashtag, this one, this one, this one, I just I can change the numbers. If anything of this, memory, don't think about it. Once you see this format, that's memory. You are gonna read from memory, you are gonna do this operation in a memory. Is that okay? Anyway, so let's see store. So here you can store register A in memory, store register B in memory. Okay, store D, register D in memory, store X in memory, store Y in memory. So these 3 instructions, D, X, Y, are for words. So they are going to take 2 locations in memory. Is that okay? So this one similar. Memory location should equal to A, similar to something like that. Memory location is equal to B, but we don't have equals. Any questions? Okay. Next one, transfer. Transfer is used if you want to copy register to register. Okay, that's easy. So no memory. Okay, no memory here. This one is used for register and register. I want to make your life easier. I want you to understand easily, right? So what should come after transfer? It has to be 2 registers. You got what I'm saying? No memory here. Okay. So let's see. So you can say transfer. You can put any one of the registers here, and then you can put comma. You can put any one of the registers here. Okay. So after transfer, you have to put 2 operands. Because what transfer is going to do is going to copy one register to another register. Is that okay? So you have to put a letter, the letter of the register, comma, letter of a register. That's it. It's going to copy this register to this register. No memory here. No memory, just register. So for example, I can say transfer A, comma B. So you are going to copy A to B. Okay. Transfer X, comma Y. You are going to copy, X to Y. Or you can copy D to X and so on. So you can select any one of here. You can copy it here. Is that okay? Great. So also we have some kind of shortcut. So we have here something like, this is an instruction, TAB. So this is an instruction, TAB. This one means transfer A to B. This one is similar if you do this way, whatever you want. So you can do this one or this one. Both are the same. It's just maybe smaller, whatever you want. Or I can say TBA, one word, TBA. So this one is going to transfer B to A, right? So I can say here transfer B to A. So if you wanna use this one TFR, it's okay. If you wanna use this two, it's okay, right? Also we have TSX, TSY. You are gonna copy register S. Do we have a register called S? Yes, stack pointer. I didn't talk much about this one because I told you this is just a stack pointer. It has a very special case. It's going to be used for stack. So it's not general purpose. It's only used for stack. So when the time comes, I explain stack, you will understand how can, like PC. PC is not something general we can use. PC is just to point at an instruction. Okay. So anyway, so we have here transfer Y to S, transfer A to P, P to A, P. Do we have a register P? Here P means a flag register, CCR. Okay. Anyway, to make everything easy, guys, I summarize all this instruction in a table. Let's see the table. So here, that's what I do in this chapter. You will see, guys, in every section, I summarize all the instructions. So this is load and store instruction. Load and store, I put them in this table. Also, here, transfer TFR, that's what I explained, guys. Also, we have TAB to transfer A to B. Okay, TBA. P here is for CCR register. We call it P. S as for stack pointer. Okay. So anyway, so this all what we have. You just copy one register to another register. Is that okay? Any questions? Okay, I'm gonna tell you something confusing and interesting now. Look here. Yeah. Let me tell you something confusing. Look here, guys. Okay, before I say it, let me explain this one first. Look here, guys. So let me ask you a question. Something looks weird here. Can I? And what it means? Look here, guys. Okay. Look here, guys. This is A is a byte, as you know. B is a byte. X is word. Y is a word. D is a word. Is that okay? You told me to select one of these and one of these. Okay. So it makes sense if you want to copy byte to byte. It makes sense. It makes sense to copy word to word, right? Because it's the same size, right? So, however, still you can copy byte to a word or word to byte. How? This is 16 bits and 8 bits. Yes, I'm going to tell you how. So if I select here, transfer X to A, what it means, right? Or when you transfer A to Y, what it means. How I can transfer byte to a word or transfer word to a byte? I'm going to tell you what it means. Because by common sense, this is 16 and this is 8. So I cannot just copy bit by bit. Okay, I have to do something because it's not the same size. Yes, I'm going to tell you. Actually, when you transfer a word to byte, for example, when I say transfer X, Y, D to A or B, you transfer word to a byte. Actually, what's going to happen, you are going to only copy the least significant byte, put it in A. Only copy the least, okay? So this is X. If I want to transfer X to A, so actually, I'm going to only copy the least significant byte. Is that okay, guys? Okay. One more thing. This is how can you copy word to a byte. So when you copy a word to a byte, actually, I'm going to copy the least significant byte only, which makes sense because this is 8 bits to 8 bits. Is that okay? But the last thing before we finish this lecture, but tell me how I would need something like that, because remember, this word is one information. This word is one information. So why sometimes only I need to take one part and leave the other part? Why? Okay, I'm going to tell you why quickly. For example, yes, the number is stored in a word. Okay, yes. But what if this number is less than 255? Yes, you are storing it in a word. But actually your number is in because the number is smaller than 255 or 255 or smaller, so actually your number is here. Right? Yes, it's stored in a bigger space, but actually that's why. That's why later in this course, for example, when you do division, if you have a number, I'm going to divide it, for example, by 10. Okay, I'm going to tell you why you are going to divide by 10 later. But anyway, when I divide by 10, and now I'm going to have quotient and I have remainder. So I am sure the remainder should be less than 10 when it, okay, and the remainder is going to be stored in a word. But I am sure it's going to be less than 10. That means it's already, yes, you are storing it in a word, but actually your actual number is in byte. You get what I'm saying? Anyway, again, this is a tool. You can use the way you want to use it. But the way, number one, you should understand when you copy word to byte, what it means. It means I'm going to copy only this significant byte. That's what it means. Okay, that's number one. Number two, in this course, how we are going to use it. Okay. Again, this tool, maybe you are going to use it for some other reason, okay? In this course, when I teach division, after we do division, the remainder is going to go to a word. If I divide by 10, for example, okay, so I am sure this number should be, the remainder should be less than 10, as I'm going to explain later, sure. And why 10? I'm going to tell you why 10 later, okay? But anyway, so I am sure the result will be stored in a word anyway, but I'm sure the result is less than 10. That means your number is here, right? We have here just zeros here, okay, because you have a small number, okay? Anyway, so for now, I'm going to continue next time, but for now, we should understand if you want to copy a word to a byte, how it works. So actually, it's going to take only the least significant byte. Okay, that's enough for today. Thanks, guys.